Good afternoon and welcome to this webinar on SSL orchestration. This is the technology we use to help customers eliminate security blind spots from their infrastructure. This is the second time we've done this webinar. We did this webinar a year ago. The session therefore is both a reminder and an update on F5's SSLO technology. My name's Stephen O'Brien and I'm joined in today's session by my colleague Mark Ward-Bopp. Mark will run the chat room and answer any questions via the chat window throughout the session. If you have any questions, therefore, as we progress through the webinar, please type them into the chat window. I've muted everyone for now, but we should have time for questions at the end of the session. We will also share the slides and the recording following the webinar. If you have any other questions, please contact your F5 account team, who I'm sure will be happy to help. And if you don't know who your account team are, then just reach out to Mark or myself and we will put you in touch with the correct team. So the security blind spot, what is it and how do we eliminate it? Why do we need to eliminate it and how can F5 help? This session will be about 15 or 20 minutes of wonderful slideware followed by a 10-minute demo. Okay. So what are we seeing? That encryption is now the norm, which is good. The figures vary, but roughly 70% of all internet traffic is encrypted, and that figure is only rising. A little bit more interesting is this statistic from Webroot taken in 2018. Webroot found that 68% of traffic from malware domains was encrypted. It's quite clear that hackers can and are using SSL or TLS now to hide cyber attacks. I will probably use throughout this webinar SSL and TLS interchangeably. Essentially, they're just an evolution of the same thing moving forward. Privacy concerns are driving the growth of encrypted traffic, which is great for you, me personally, as our data is more secure. But this can be a problem for the IT security team. The increase of encryption creates a blind spot for the security devices that you've purchased to protect your organizations. So just a little bit about the business drivers that have increased the requirement for SSL, or should I say TLS encryption. If we look at Office 365, for example, Office 365 traffic is becoming very large, so much so that some web proxies products have a difficult time in handling the load. We also live in a world now where Google search results are being ranked based on good encryption standards. Therefore, there is potentially a direct correlation between business success and good encryption standards. As I've already mentioned, there's an increased growth and focus on user privacy, which I'm sure you also understand is being driven largely by compliance requirements such as GDPR. A little bit more about business drivers. So at F5 Labs, we have a research team called F5 Labs. So we sent them off and they spoke to a financial services organisation and a healthcare organisation. We anonymised the data for the purposes of this webinar, but we asked them what the challenges with SSL or TLS was. And first of all, from the financial services organisation, it was that existing security devices couldn't cope with the load. When they switched on decryption, the devices started to struggle performance-wise. The existing security devices as well didn't have the capability to deploy perfect forward secrecy and modern algorithms. And a little bit more about that later. And their existing proxies were unable to redirect Office 365 outbound traffic, leading to congestion on outbound firewalls. Just a little aside about Office 365, per user, we were expecting 20 to 40 connections per user. So depending on the number of users within your organization, that could be quite a heavy load on your infrastructure. So moving on to the healthcare use case, and the number one priority, again, was that the security devices couldn't cope with the load. This organisation specifically said when they switched decryption on their perimeter next-gen firewalls, they peaked at 100% CPU and they had to switch the decryption service back off on those devices. Fundamentally, their great technologies, but the appliances are not built to deal with encrypted traffic. And they also wanted to decrypt and encrypt SSL data without sacrificing performance. We flipped the question then for these customers and asked them what they really required from an SSL orchestration solution. So for the financial services, they wanted a single point of control for decryption and re-encryption of the traffic. They wanted support for perfect forward secrecy and for advanced cryptography. And they wanted the ability to steer traffic, Office 365 traffic or outbound. For the healthcare organisation, they wanted that single point of control again, that single point to decrypt and re-encrypt. But conversely, they wanted stronger accountability and customer trust. This essentially was patient data, your and I's patient data they're handling, and they need to be able to build trust from their customers. They also wanted the accumulated logs to be sent off to SIEM solutions for forensic analysis in the future. Now, a little bit about what the challenges of encryption are. There's a number of challenges caused by encryption. Gartner actually believed that by 2021, more than 60% of organizations will fail to decrypt HTTPS traffic efficiently, and in so doing, they'll miss most targeted web malware attacks. So visibility is the first thing that we need to do. We need to be able to see the traffic to be able to take an informed security decision on that traffic. If we don't decrypt, we're blind. I always give a view on this is the Madagascar penguins. My kids love the film Madagascar, and it's that view when the penguins are smiling and waving as everyone goes by. Well, it's very much the same with encrypted traffic. If you're not decrypting, you're smiling and waving as all the malicious content just flows by your devices. Secondly, we need performance. As I've already said, many security devices take a big computational hit when they try and decrypt at scale. And in some cases, they just can't scale. You're caught with the problem of enabling visibility and reducing the performance of your infrastructure. But if you don't decrypt, as I've already said, you're blind to the potential attacks. And then finally, complexity. IT complexity is not helped by security device chaining. And I'm going to review that now. So security teams have to deploy a wide variety of security devices. Typically, this is done in a security daisy chain. For example, internal traffic talks to an IPS, which passes to a web gateway, which passes to then the DLP solution, and then to the sandbox, and then finally to the firewall before being sent on its way to the application. This creates multiple intercept points and the potential for multiple points of failure. The multiple decryption and re-encryption creates increased latency in your infrastructure, and it's also that IT complexity that I previously mentioned. If something goes wrong, if one of these devices starts to have a performance issue or starts to fail, then your whole data center could be compromised. To get around this, organizations need to have a device with a full proxy architecture. A full proxy negotiates separate encryption standards from the client to the full proxy, and again from the full proxy to the server. You all know that F5 is a full proxy, right? And you also know that F5 is a device that will provide a single point of decrypt and re-encrypt. And then with advances in cryptography, such as perfect forward secrecy, if the security device is not actively taking part in the negotiation of the protocols and ciphers and does not support the protocols and ciphers that the client and server then negotiate, then many of the security devices are unable to perform decryption, and they have no choice but to bypass the traffic. And that's the power of the full proxy, as I said. So, what capabilities do we require from an SSL orchestration solution? It needs to have support for the wide range of security devices that your organizations have already deployed, and it needs to be able to support them in a number of network topologies. For example, a layer 2 or a layer 3, an ICAP or a TAP connection. We need to be able to support all these modes of connectivity. We need to support dynamic service chaining with traffic steering as well to replace this out-of-date and inefficient daisy chaining of security devices. And then finally, we need centralized management of certificates and keys. We need proxy level control of the ciphers and protocols, plus the capability for load balancing, the ability to remove a failed device dynamically, and the ability to scale and monitor individual security devices if required. So at F5, we have built F5's SSL orchestration. It is a purpose-built solution for the orchestration of inbound and outbound SSL TLS traffic. We break the daisy chain paradigm. F5 solution provides a single intercept point that does the decrypt and re-encrypt just the once. We're the only device in the data path, and we steer the traffic in clear text to your existing security controls. Existing security controls are now able to see 100% of the traffic in clear text without the computational overhead of the decryption and re-encryption of that traffic. The security team can now apply context-based rules to the handling of the encrypted traffic flows. And this is all done using a guided config. That guided config I'll show you during the demo, and you'll see how simple that is. We remove that IT complexity that we discussed earlier, and I'll show you this again in the demo. SSL Orchestrator also lowers your security costs both computationally and economically with intelligent load balancing and monitoring for better availability and utilization of your existing solutions. Essentially, under the hood, we're a load balancer, so that active-passive security solution can become a load balance pool of active-active devices with F5 balancing the traffic across your security solution. It can also enhance your organization's privacy and security with improved efficiencies and, crucially, will eliminate that security blind spot and will remove the performance challenges associated with today's encrypted world. So F5, we believe, has some key technology advantages. So just to run through them very quickly, we have the ability to dynamically scale, independently address services that can be scaled irrespective of other security services. So once we put a security service into a pool, we're moving it from active-passive to active-active, and should it then have a performance issue in the future, we can add another node into that pool to increase the scale of that service. We have dynamic device support as well. The F5 full proxy architecture allows it to address Layer 2, Layer 3, HTTP services, TAP and ICAP services. So however your security device needs us to integrate with it, we can. And also device service chaining, forwarding traffic intelligently to the various security services based on a traffic classification. I'll look at this in the next slide in more depth. And we also need cipher diversity. As a full proxy architecture, F5 performs separate client-side and separate server-side TLS sessions, so cipher and protocol mismatches never ever happen. We will always be able to get the traffic in clear text to your security solution should you wish to do so. So, I've mentioned dynamic service chaining a few times. So what is it? It's probably best described by example. So if we have a look at this web traffic here, the web traffic is intercepted, it's decrypted, it's passed to the firewall service, then it's passed to the advanced persistent threat service, then to the next gen firewall service, finally the DLP service before being re-encrypted and sent on its way. Conversely, if we look at finance and health, now most organizations will have a security policy that states that finance and health traffic should never ever be decrypted, because that's my banking details, it's my health details potentially, and we shouldn't open that up to inspection. So for the finance and health, we choose, once we've categorized that flow of traffic, we bypass, we don't decrypt that traffic flow. In this example, we're only passing it through the IPS before sending it on its way to its destination. Now, A more interesting case is the test traffic example I have here, where we may want to look at an upgraded version of an existing solution, or maybe a new vendor solution, as I have in this example. So again, the test traffic could be a test team for a proof of concept. It could be the IT team that you're using here. So we can identify traffic from the IT team, for example. We'll intercept it, we'll decrypt it, we'll pass it through the firewall, and then that new vendor service that we're running the proof of concept on. When you're satisfied with that new vendor and you want to integrate that new vendor into your web traffic flow, we can simply move that new vendor into the dynamic service chain for web traffic. We'll talk a bit more of that, and I'll show you that in the demonstration again. Now, just a little bit more on dynamic service chaining. On the left-hand side here, we will create services. Again, in the demo, I'll show you how we create services and how we can create different types of services. We've got, for example, here a FireEye service in layer 2. We have a receive only, possibly a SIEM solution. An inline layer 3. Now, in this example here, it's Palo Alto. It could be a checkpoint firewall, it could be a Fortinet or Sophos firewall. Whatever vendor you've got, we can integrate with it. Again, it's a Cisco web proxy in the example here, and then 2 ICAP services. Now, what I wanted to draw your attention to here on the right-hand side was the 2 different service chains, which actually have the same services in them. The FireEye, the Palo Alto, and the Cisco service are the same services, but they're used in different orders. Now, that is a very simple process that any administrator can set up in SSL Orchestrator, and I'll pull that out as I go through the demo as well. So, as you've already seen, F5 has multiple partners in the SSL Orchestrator ecosystem, and working with these partners, we've created a number of joint integrated deployment guides. As you'll see when we run through the demo, we also have support for generic layer 2, layer 3, rooted HTTP, ICAP, and TAP solutions. So whatever way you need us to integrate with your security service, then we can. So just a little bit about where you can deploy SSL orchestration. So it could be a standalone or an HA solution. It can be a physical or a virtual format, and it could be an add-on license to your current platforms. We support VCMP on our Viprion and our higher-end appliances. If it is an add-on to an existing appliance, we would have to do a due diligence and get your F5 team to check that there is capacity on that appliance, but it's certainly something we could look at and we could investigate. We can go on-premise, we can go private cloud or public cloud, or we could be co-located. So wherever you need us, we have a solution for you. Okay, that's enough slideware. So let's have a look at the SSL Orchestration GUI. So this is the SSL Orchestration GUI, and I'll step you through the guided configuration here in a moment. But as you can see, once it's configured, this is a layer 3 outbound flow that I'm using for the demonstration. I've got several devices that are connected to my SSL orchestration. I've got a TAP service from Cisco, a FireEye service, a DLP service, a generic layer 3 IPS service, and a Cisco web proxy service. If I just step into the guided configuration, and as you can see, we have a step-by-step process through this guided configuration at the top here. Now, if I just step into it, so the topology, we select a topology for the flow of traffic across the SSL orchestrator. Crucially, we can actually go in now as a V-wire, so we can go in as a bump in the wire into an existing infrastructure. So just unplug a VLAN in one side of the SSL orchestrator, out the other side in your existing infrastructure. So we don't have to disrupt and reconfigure an existing infrastructure to get us into the data path. But you can see the different options that are here: layer 2 outbound, layer 3 outbound, a layer 3 explicit proxy, layer 2 inbound, layer 3 inbound, and an existing application. If we step on, the SSL configuration, one piece I want to pull out here is the fact that we are using an internal CAA for this flow of traffic. So we have generated a certificate and key pair, and we've published the public certificate to the clients within the organization through group policy. This just enables the SSL orchestrator to step in silently and invisibly to that flow of client encrypted traffic, decrypt the traffic, and then re-encrypt as it goes outbound. So services, so on this, as you can see, I've got the 5 services created. I'd like to just step into here to begin with to show you the deployment guides that we've got for various vendors. And at the bottom here, if you're not in our current vendor list, which is always expanding, we've got generic services, which will get you 95% of the way there with your configuration very quickly and very easily without having to think very hard. If I step back and have a look at some of these services, we've got, first of all, the FireEye service. So if we just let that start up, this is one of our confirmed deployment guides. And all we've done here really is create 2 VLANs, an external and an internal VLAN that we're going to send the traffic across to the FireEye solution because it's listening in layer 2. So we're going to decrypt the traffic, pass it out these VLANs and back in from the FireEye on the other VLAN. Let me just step out of this and have a look at the SSLO IPS configuration. This is a generic inline layer 3 service. And as you can see, one thing to pick out here is this auto manage of addresses. So each of the deployment guides has its own unique address space that F5 have set out already. All that's doing is, if we follow that and use the auto-managed address space, it means that you're never going to have an overlapping, no one's going to make a mistake and have an overlapping address space. And all we have to do is provide the IP address of the device. I've got a single device in here, but I could add others and make that a pool, and F5 will then just normally and naturally just start passing the traffic across that device or the pool of devices. So once we've got our services defined, we can create our service chains. For this demonstration, I've created 2 service chains. I've got my all services, which actually contains all the services I have available. And as I've said previously about the ordering of the services and service chains, we can change the order by the simple use of the up-down buttons. Let me drop out of that and just show you the other service chain, the layer 2 service chain. And again, we could reorder these services should we wish to do so. Once we have our service chains, we can create a security policy. We have this pinners rule to begin with because devices such as our apps on our phones will have pinned certificates which we can't step into, and that's common for all SSL orchestration devices. We have to bypass that traffic. The second rule we have is a URL bypass rule. So if we just inspect this rule and see what we've got configured in here, we can see we're looking at financial and data services and health and medicine. We could add in other categories in here should your security policy for your organization need another category in there. It's simple enough to add it in, and then we're going to pass the traffic forward. The all traffic, which is all other traffic, if we inspect that one, we're going to intercept that traffic and pass it through our SSLO all services service chain. So that's a very simple overview of the security policy. The interception rule outbound is we're looking at all addresses to intercept and pass it through our security policy that we have created. We have an egress setting where we're actually defining the default gateway to pass the traffic to after the SSL orchestrator, and we're going to use automap, so we're going to hide the outbound traffic behind the external interface of the SSL orchestration device. We have some log settings which we can configure, and then we get a summary of everything that we've configured, and once we're happy with that, we can deploy that policy and we're up and running. So just to have a look at, let me just grab this. And let's have a look at google.com. And we'll inspect the certificate here. And we can actually see, if we view the certificate, that we've stepped in with our subordinate, our internal certificate authority certificate that we've published. So there was no warnings for that user as they went outbound to Google, no pop-ups for that user interfering with their use of the Google service. But if we compare that now, let me just change this to a banking site. So let's choose the Royal Bank of Scotland. Let that page load. Just give it a moment. There we go. And this time, let's have a look at this certificate. View the certificate. And because this is now financial and data services, we can see that we've actually used the CA certificate. So we've bypassed that traffic outbound. Okay, so we've got a working configuration up and running. Let me just step back into this demonstration. I've got a couple of slides just to finish off. So when we did this demonstration a year ago, it was our version 4 of our service. The version I've just shown you is 7.1. We've introduced a number of things which are important across the way. As I've already mentioned, we've introduced VCMP support. So this can be a component on an existing platform that you've got, and just in a VCMP guest instance, if you've got the capacity to do that. We also introduced TLS 1.3 support. So that brings us perfect forward secrecy as well. And layer 2 enhancements in version 7. So we can now go in as a virtual wire, so a bump in the wire into your current infrastructure. And then finally, I'd just like to bring your attention to version 8, which will be coming out, we reckon, in a sort of a May-June timeframe this year. So everything that we're doing, we're going to start introducing the ability to integrate with F5 services as well. So our WAF service and our secure web gateway service. The Office 365 integration already exists. Currently, it's done through an I rule and some data groups on the F5. What we're doing in version 8 is we're moving that into the GUI to make it more simple for you to configure and manage on an ongoing basis. So one final summary slide is just a bit of a summary of everything we've gone through today. So we go beyond visibility. We give you that centralized decryption and policy-based traffic steering across multiple security tools. We can deploy into any environment. We are absolutely agnostic to any environment that you have, so whether it's public or private cloud, co-located or on-prem, we can do all of it. And the dynamic service chaining, it's a unique point that F5 can do that none of our competitors can do, and it really brings a real flexibility, as I said during the demonstration, to maybe look at upgrades or test traffic for proof of concepts. So it's very, very flexible. So with that, that brings me to a close. I'd just like to thank you for your time. I appreciate that it's a large investment of your guys' time. If you have any questions, please reach out to Mark or myself and we'll happily answer them. We'll share the slides and the recording of the demonstration in due course. Thank you.